Hello students, here is the video for quadratic review with completing the square that I'm assigning for Tuesday, May 14th. It's review, and I'm hoping that this video will help for our test on Thursday. Okay, right now I have the direction to factor each completely, not to solve. And in this expression here, we have a quadratic term, a squared term, and an x term. And I don't have a c. Remember, standard form would be ax squared plus bx plus c equals y. And I don't have a c here. And I'm going to go ahead and use the greatest common factor rule to factor out an x. And then I can just call it factored. See, x here is a common factor, and x here. There's no number that's a common factor, so I'll take out an x, and what's left when you divide 7x squared by x is 7x. Or another way to think of it is x times 7x is 7x squared minus, and then 2, if I divide that by x, and it's factored. We've done this many, many times. Okay, so number 2 you can do. Now number 3 has 3 terms. We have a squared term and an x term and the c. We'll use a diamond to see if we can factor it that way. And I'll put a times c up here, which is 1, a times c, and then negative 2 down here. Two numbers that multiply to 1 but add up to negative 2 would be negative 1 and negative 1. Ooh, negative 1 times negative 1 is 1, and they add up to negative 2. Now, because this leading coefficient of this trinomial quadratic expression is 1, I can just take the factors directly from the diamond, x minus 1 and x minus 1. And a better way to write this would be x minus 1 squared. And that's factored. And remember, I'm not being asked to solve. Now I notice that this was a perfect square trinomial. I could have just taken the square root of x squared and the square root of 1 and set that into my factored form, but we'll do those later. Okay, number 5. Now I have a trinomial quadratic expression. I'll go ahead and make a diamond and hope it's factorable. 5 times negative 8 is negative 40, and negative 6 is the b, goes down here. So some factors I can multiply together to get 40 would be 4 and 10. Oh, 4 and 10 will work fine, because if I have a negative 10 and a positive 4, they'll add up to negative 6, but multiply to negative 40. Now the leading coefficient in this expression is not 1, so I will need to factor by grouping 5x squared, and then rewrite the middle term as negative 10x plus 4x minus 8. And now I'll factor out the greatest common factor on each of these. That's 5x times x minus 2 plus 2, oops, I can take out a 4, plus 4 times x minus 2. Matching binomials is what we're looking for here. And I'm going to take x minus 2 out and then multiply it by 5x plus 4. And now it's in factored form. And remember, I don't have to solve. And you'll do the same thing for number 6, factor by grouping. Okay, now number 7 and 8, I'm being asked to solve. And I'm noticing that I don't have a squared x here. I have a cubed x. And I have an x here. So what I'm going to start with is factoring out the greatest common factor. The greatest common factor would be x. So if I factor out an x, I'm left with x squared minus 1 equals 0. So the x is easy to find the value for, but we need to see if we can factor this also. This is a difference of 2 squares. And if you can remember how to do that, it's quicker. But I'm going to go ahead and factor that. We have a squared value in here. You might be able to figure it out just by looking at this. But I'm going to go ahead and factor it with a diamond. So we're going to have x times something. It's going to be x times x squared plus 0x minus 1. I'm rewriting this with a 0 here. So then I'm going to factor what's inside of here, because I've already taken out the x, so that's already easily solved. But this needs to be factored to solve it a little more easily. So the diamond gives -1 on the top and 0 on the bottom, and so 1 and -1 will be my factors. So I'm going to have x times, now this leading coefficient is 1, x squared minus 1, the leading coefficient is 1, so I can take the factors right from the diamond. So basically I factored it and then factored it again, factored what was in here. There are more than one ways to solve this right here for x, but one way would be to just make your diamond and factor it, and there it is, and that equals 0. So now my solutions are going to be when x is equal to 0, when x plus 1 is equal to 0, and when x minus 1 is equal to 0. Well, if x plus 1 equals 0, then that means x equals -1 is a solution. And when x minus 1 equals 0, if we set that factor equal to 0, we get x equals 1 as the other solution. Those are the 3 solutions. So this equation has 3 solutions. 0, -1, and 1. And this was the factored form right here. Took out the greatest common factor and then factored what was left, which was x squared minus 1. And that's the difference of two squares. B is equal to 0, and so I could use a diamond and then B equal to 0. There are other ways to do that. Okay, number 9. The directions say, find the value of C that completes the square, then factor the perfect square trinomial. So here is our C, and in order to make this expression, x squared plus 16x, into a perfect square trinomial, we have to take the coefficient of x, that's the b term, divide it by 2, and square it. So if I take 16 and divide it by 2 and square it, I get 8 squared, which is 64. So my perfect square trinomial is x squared plus 16x, and the value for C that makes this a perfect square trinomial will be plus 64. Remember, perfect square trinomials always follow this pattern. They follow the pattern where the last term is the middle term divided by 2 and squared. So now this is a perfect square trinomial, and so I'm going to factor it. To factor it, I'm going to take the square root of the first term, the square root of the last term, and then that's going to be squared. That's how you make the perfect square trinomial, is with a binomial squared. And then in the middle, I have plus and plus, so it's going to be a plus. So I made the perfect square trinomial by taking half of the b term and squaring it, and so that's the C. So C is equal to 64. Well, when I rewrite it with C being 64, then I can factor it, and now that's the factored form. I'll do number 11. C is going to be equal to, well, I have to take -30 divided by 2 and square it. So that's -30 divided by 2 is -15. -15 squared is 225. Remember, you should have these perfect squares starting to get memorized. 15 times 15 is 225, and since they're both negative, we still get a positive 225. So my C value is 225. That is the value that will make this a perfect square trinomial. I'm going to rewrite it, x squared minus 30x plus 225. That's the C value. Now this is a perfect square trinomial, so that means it comes from a binomial squared. And the binomial squared is going to be the square root of the first term, the square root of the last term, which is 15, and we have a minus and a plus, so this is going to be a minus binomial, x minus 15 squared. Now if you want to check it, you can just multiply this out. X minus 15 times x minus 15. So that's x squared minus, x squared. Let me just do the x's first. So x squared, I did it again. X squared Now I'll move this, use this, that's minus 15x, and then I'll use that again, and that's plus 225. So if I simplify these, I get x squared and then minus 15x. Minus 15x is minus 30x. It's a minus there. Plus 225. And so I end up back with the perfect square trinomial. So perfect square trinomials follow patterns, and we can easily factor it when we recognize that they are perfect square trinomials. So here you're just going to take half of that value, the b value, square it, and that's going to be your c, and then factor. Okay, 13. The directions here say change the standard form equation to vertex form, then find the vertex, the axis of symmetry, and the y-intercept. So number 13, I'm going to change it into vertex form. How do we do that? By completing the square. So we need to complete the square, just like we were doing up here, and then factoring. So watch what happens. This is review. So y equals x squared plus 2x. Now I'm going to move this minus 3 all the way over here. I'm going to complete this square here by taking this term, the x term, dividing it by 2 and squaring it. So that's 2 over 2. That's 1 squared. So I get x squared plus 2x plus 1. And then I have to subtract 1 to keep the equation equivalent. So now I can factor this first trinomial, and I get x plus 1 squared. How did I do that? Took the square root of that, took the square root of that, and I have pluses, and so it's x plus 1 squared. So this perfect square trinomial has been factored. Then I have minus 4 on the outside. I just combine negative 1 and negative 3. There is the vertex form. Y equals x plus 1 squared minus 4. Well, the vertex comes right from the vertex form. It's the opposite sign of what's on the inside here, which is negative 1. And then the k value is negative 4, or the y value for the vertex. The axis of symmetry is always equal to the x value here. So it's equal to negative 1. Because the vertex, the axis of symmetry always goes through that vertex. So the axis of symmetry always goes through the vertex. And so if the x value of this, if the x value of the vertex is negative 1, then the value of the axis of symmetry is also equal to negative 1. You can see this better from a graph. And you'll do a little graphing on the next page. So number 14, go ahead and complete the square, and then factor the perfect square trinomial, etc., to change this into vertex form so you can find the vertex and the axis of symmetry. Now, one thing I forgot to do is the y-intercept. Now, the y-intercept is not equal to negative 4. It is not equal to negative 4. If you let x equal 0 in this equation, then you'll find the y-intercept. And what happens is 0 plus 1 is 1 squared, so that's 1 minus 4, so that's negative 3. So your y-intercept is equal to negative 3. Or you could look at the standard form equation, and that's the y-intercept. So don't take it from the vertex form, that's wrong. That's not the y-intercept. You can take it from the standard form, or you can let x equals 0 in the vertex form and solve for it that way. Okay, next page. So number 15, I'm still asking for you to put this into vertex form and then find the vertex and the axis of symmetry and the y-intercept. I'm going to stop this video and I'm going to do this second page in part 2.